The datum alignment or iterative alignment is a DCC function only. You must have an alignment set up ahead of time. That could be a fixture position, that could be a manual alignment. It really doesn't matter so long as you're locating the part to the CMM home position. Then the datum alignment can take over and further align your part to be more accurate. That is the purpose of an iterative alignment. In this video, we are going to perform a datum alignment. In the alignment ribbon bar, choose the datum icon. Now, the datum alignment is an iterative based alignment. What that means is it will take the nominal from the points that we pick on the CAD model and compare them to the actuals that are actually physically measured on the part. And the software will mathematically align these parts through an iterative process of remeasuring and remeasuring until it gets to a desired tolerance amount. So let's put the points on the model. We click the Point tab, Add Pick under the Graphic Tool menu. Now these points do not have to be at the same height or on the same surface, but what we're trying to do is to pick points that will constrain this part and place the alignment where we've asked it to be placed. So when you're done picking, click the Escape key, and that brings up the dialog box. Let's create a path for our pro points. So click Create Path, come back to the alignment. Now, this minimum iterative is 1 to 3. Let's increase this number to 5, and let's create a 1/1000th tolerance. What this means is this program will run at least twice, and then it will check the tolerance between, or the delta between, the first measurement and the second measurement. If it's within 1 thou, the iterative will stop. If not, it will run a third time and check to see the delta between the last two runs, and a fourth time and a fifth time until it either reaches the 1/1000th tolerance or it reaches the number 5 measurement runs. If you'd like to confirm if it's out of tolerance, this will pull up a message telling you that you are out of tolerance. It did not meet the 1/1000th tolerance before it ran out of iterations. Okay, click Apply. Click OK to accept the datum alignment into the program. Now, when you go to run this part program will run CNC and remeasure those points once again and keep measuring them until it meets either the tolerance or the max iterative that we put into the part program. Let's open up the datum alignment, unlock it for editing, and I want to simulate the path. So let's click Simulate, and notice I'm at Iterative Best Fit. Iterative Best Fit is going to take 3 points and take a center point to determine what the vector of the probing should be. So if you have a part that has some odd surfaces, this is probably the situation you want to have, is to use the best fit. The iterative 3, 2, 1 just takes the single points in the vector that was taken off the CAD model. Now let's see the iterative alignment in action. As you can see, each time it runs through an iterative alignment, it shows the RMS number. Remember, this RMS we asked to be below 1, so it will continue running the alignment routine until the RMS meets the 1,000th deviation between the two previous measurements. When this is complete, the window will close and you're ready to program the rest of your part.